Hello, welcome back to CTOCon 2023. We have a great fireside chat on engineering for privacy, balancing privacy and compliance with data usability. My name is Sean Falconer, and I am head of marketing and developer relations at Skyflow, and I'm honored to be your moderator for today's discussion. In today's rapidly evolving technological landscape, ensuring security, privacy, and compliance has become increasingly difficult for individuals and organizations. The rise of cyber threats and the exponential growth of data collection by organizations highlights the importance of prioritizing and maintaining security and privacy. However, there's often a trade-off when we prioritize privacy because the additional security involved can make using the data we collect much harder. Ultimately, we collect that data about our customers so we can use it to hopefully develop a better product, deliver higher ROI, and build a better business. During this fireside chat, we will explore the most significant challenges organizations face in maintaining security, privacy, and data usability, and how to overcome them. Join us as we engage in a meaningful conversation and learn from our guests, the chief architect of Skyflow, Manish Ahluwalia. Manish has over 2 decades of experience in software engineering, having developed critical and performance systems across a wide variety of companies from SaaS, enterprise to consumer. He's also worked in security for over 10 years and now serves as the chief architect of Skyflow. He's one of my favorite people to talk to because I always learn something new. Manish, welcome, and let's get started.
Hey, thank you, Sean.
Awesome. So we have limited time, so I want to jump right into things. How has the landscape of data privacy and security evolved in recent years, and how has this impacted how businesses manage and protect the data? And ultimately, like, how should engineering organizations think about this problem?
So there's a lot in that question. But you reminded me that we have a limited amount of time, so I'll try to keep this quick. The landscape of data privacy security has been changing quite rapidly, and the reasons can be summed up in just 2 points, which is basically breaches and hackers and government regulations. For both reasons, companies are starting to realize that this is a problem that they need to get in front of. You don't want to get fined. You don't want to be on the front pages of your favorite periodical, Hacker Noon, whatever, etc. So folks are starting to pay attention. So you also asked about like how are engineering organizations managing this. So again, these regulations are now filtered in. As the privacy regulations obviously filter in through the business needs. You want to operate in a particular geography. There is a government regulation out there to do X, Y, and Z, and you need to do it. But what's also happening from the engineering perspective is there are a bunch of like standards that are coming into place. There is a bunch of patterns that are coming into place. In terms of standards, you'd see like there was the ISO 27001, which is a couple of decades old standard for security. Well, ISO recently, like 5 years ago, came out with one for privacy as well. Similarly, NIST had a cybersecurity framework for a very long time. They enhanced it to add privacy also as well. And of course, government regulations keep changing all the time. But sorry, I didn't mean to just stop there. What engineers are also getting is like a bunch of guidelines in terms of here is the right way to do it, because it's one thing to just give them a bunch of checklists and say like here is a bunch of problems you need to solve. It's a whole another to give them like the right kind of patterns to think about. So there's a whole privacy by design scheme that's becoming popular, and plus there's also like smaller patterns that are coming in all over the place, like how you solve a specific problem with privacy in mind. Tools are getting developed like homomorphic encryption and allow differential privacy, etc., things like that. So the landscape is changing both in terms of what engineers need to do and also in terms of tools and architectural patterns that they can adopt.
Yeah, so you mentioned these standards like ISO 27001 and how that's a decade old standard in relation to security, and now they're starting to come out with standards around privacy as well as these different patterns. What's it mean, I guess, for an organization to engineer for privacy versus security, and ultimately, is there a difference there?
Good question. So they are very related, of course, but there is a significant amount of difference in them. So let me just tease apart both of those. So obviously, let's just take some very basic things. So if you're looking at security, whether you're following the NIST standards or whatever, you're taking care of like confidentiality, integrity, availability, auditability, the CIA or ISC or however however you call it. Obviously, if you can't guarantee confidentiality in your system, if you don't have auditing in your system, you have a very hard time guaranteeing that if you don't know who's reading your data, you don't know that the purpose of reading is legitimate and commensurate with the value you're offering the consumer, right? So obviously, if you do not have confidentiality solved as a problem, you do not have privacy solved as a problem. But privacy is a lot more than just guaranteeing security. It's kind of like maybe security is just like the basic building block you need to step off of. Privacy means a lot more as well. Privacy is about what is the adequate use of the information, and security is just so security is a little bit more technical, and in the sense that the problem is defined technically. Obviously, in these both cases, the solution is coming out is going to be technical, but in privacy, the problem starts from a business statement. You are going to be collecting payments, so the PCI industry standards apply to you. You're going to be operating with health data, HIPAA applies to you. And that's not the requirements aren't coming in from a specific technical need, they're coming in from a regulatory framework. And then, of course, that means that there is a lot more to be done than just securing your data.
Right. And you mentioned at the beginning that there's, in terms of what has changed in this landscape, there's both the change that has come from regulations, and then there's also the increasing number of essentially like cyber criminal activity that's leading to data breaches. Between those, what is the biggest challenge that businesses face when actually trying to secure sensitive data, and how are those challenges actually being addressed by companies today?
So the biggest challenge that most companies would probably run into is I guess depends on who you're talking to in the organization. But let me just list out a couple of things. The biggest problem often is sprawl. There is data in so many places, in so many different formats, legacy systems you cannot touch, and that's been stored in various different storage solutions, on-prem, cloud, etc., etc. Just getting a handle on what is the exact scope of the problem becomes a major effort in any reasonably sized company, in a large enterprise specifically. So that's like, how do you get started? But even once you know that there is a specific problem, you may be able to find like an S3 bucket that has a whole bunch of sensitive information. Great. You know what you need to do at the very basic level. You need to go like encrypt it, lock the bucket down. You don't want to do anything that breaks somebody who's reading it, of course. Maybe it had information that didn't belong there. It was storing card numbers. Well, now you want to figure out where are the card numbers coming from? Let's take them out. And now you run into legacy systems. How do you incorporate the right way to do it in those legacy systems? So it's basically getting a handle on the scope of the problem, getting the ability to make all these changes in the systems that work with all of this data. I guess would be the two very broad ways to characterize the problem.
Yes, you mentioned essentially that at the heart of this problem, or where a lot of companies struggle, is essentially there's data sprawl. So data ends up in lots of different locations, which means that the scope of the problem ends up being really large because it's essentially touching all these different systems, and it's hard to even track down where that data is. And if you can't track it down, it's hard to know whether you're actually protecting it. So is that sort of the root of the problem for a lot of companies that's leading to the challenges that they're having around data breaches?
Well, data breaches is a lot more than just that, but that is essentially a very large part of the problem. Is finding out where your problems are, finding out who's accessing them, and all of those are important to be able to work back and answer the question of, is this secure? And also, second, from the privacy perspective, is this use really needed in the first place?
And you mentioned this idea of, you could have a situation where you have an S3 bucket that has a bunch of sensitive data in it. And, the things that you need to do there is make sure it's encrypted, lock down the bucket. But at the same time, you need to make sure that people who should be able to read the information can actually read it. So How can businesses sort of balance this challenge between data security with data usability so that people who should be able to see the information can still see it, but that ultimately the data is also very secure and keeping the bad actors out?
Right. So that is, of course, in this case, the million-dollar question here, and that's where you have to kind of go at the problem not just with like a hammer, but like well, I mean, you can use your metaphor that that's the opposite of the hammer. But the point here is you need to kind of approach the problem with, is the problem the S3 bucket? Because that's how most people solve it, as like, what can I tighten in terms of my infrastructure that solves the problem for me? And definitely infrastructure security is important. If then there's an S3 bucket that doesn't have encryption, turn it on. But that does not necessarily solve your entire problem, because now folks who are reading the bucket can still continue reading the bucket perhaps. And if they weren't supposed to read the bucket, if from the privacy perspective, if that access to the bucket itself was what was causing a privacy problem, or the tool that's reading the bucket and displaying the bucket itself has a security breach, you haven't really solved the problem. What you need to look at is not just the infrastructure that works on the data, but actually the content of the data itself, and look at like what part of the data actually should really not even be in the S3 bucket, or what aspect of the data that you have in the S3 bucket is needed in the bucket and not. And what can we move to? As an example, for instance, we talked about card number. So let me continue using that example. Does the card number belong in the S3 bucket? Maybe not, but if you try to rip it out, maybe somebody dies because there was some process dies, excuse me. I hope no human being dies because some process dies because they were looking at the bucket to find out like, do I have the same card number as a duplicate in some case? So you want to be able to continue maintaining that business flow without your security and privacy controls getting in the way. Because the last thing you want to do is that somebody who really relies on this data can't do their job because of some control you added.
So how are companies traditionally trying to approach this problem from an engineering standpoint?
So a little bit going back to the privacy versus security thing, right? So most people have started getting the idea that like, okay, here is the way I make sure my data is secure. And security, like I said, is super important. You should definitely get it right. And security will kind of give you, at the very least, a checklist. So if you're in AWS, for instance, AWS got like, here's what it means to be well architected. Security is a pillar of well architected, and here is how you go secure your data, your systems, etc. And a similar pattern for pretty much anything else you're doing, like you're writing a Ruby application, Ruby on Rails, and there'll be a checklist for how you secure this. There's a whole bunch of tools. Privacy doesn't have even nearly as many tools. It's a slightly fuzzier problem at this point in time. But there's a similar like privacy by design like checklist you could create out of that. There are privacy frameworks, like I mentioned, you could follow. So most people are kind of have converted this into let's arm a team with oversight powers and give them the right standards to follow, the right checklists to follow, and just basically solve the problem that way.
Mm-hmm. So that's maybe what companies are doing around building these checklists and approaching the problem like that. But in your opinion, what is the most effective strategies for actually protecting sensitive data, and particularly in a cloud-based environment where a lot of businesses are moving towards, or where a lot of business is done today?
Yeah, the problem with the checklist approach and things like that is it kind of creates almost not necessarily an adversarial kind of a relationship. It kind of says the engineers need to build your systems, and there's this other group of people who are kind of like giving oversight on what you're doing. Right. On the other hand, you could look at this as, so if you take a look at quality, right? There used to be engineers and QA teams. And now the paradigm's a little bit like, you are responsible for the quality of what you write. So you make sure you got your tests and all. That doesn't mean there isn't a QA function. And there's like testing at different levels. But you've pushed a lot of the responsibility of quality right down to developers. Similar things like on the security front, there's been like shift left. So you move the security responsibility again to the developers. Similarly, it's not that if we have the right tools, the right framework, the right thinking, we should be able to move some of this responsibility for effectively the whole data protection posture of the company also onto the engineers themselves. To do that, we need to give them the right tool. To kind of use like going back to the same S3 bucket with card numbers example, right? Mm-hmm. The engineer needs to store something somewhere because they are ingesting data, and there is a different engineer that needs to read this data. If you had a holistic understanding of your data protection posture in the company, the engineer who's writing it would have the ability to write the right amount of information. In this case, like maybe a fingerprint of the card or some such thing, so that the engineer who needs to read the card, read the S3 bucket to evaluate that, to perform that computation, can still continue to do her job. That would be ideal. Better still, the system should not have access to any more information than they need, right? So if you knew, if the corporate posture was like, we'll take the card numbers, we'll charge them, but we do have a need to figure out that the same card number has been used twice. Well, maybe that's all you give access to the system to. So the engineers don't have to kind of like figure out between themselves what do they need. Mm-hmm. Again, a similar concept as we've had for quality and security is just give the developer the right tools so they can make the minimal decisions that they have to.
Mm-hmm. Absolutely. And then, I think that's a good jumping off point in terms of the right tools and also shifting privacy left so that it becomes like a part of the engineering process. A good time to talk about Skyflow. So what is Skyflow and how does it relate to the topic that we've been discussing?
So Skyflow is a data privacy vault as a service. The whole idea of a data privacy vault, like a data vault for privacy, etc., is that we've done the homework in Skyflow of figuring out that, look, privacy in the S3 bucket, mostly you would be worried about the S3 bucket not for the vast majority of its contents, but just for certain specific things. In our example, card numbers, you could have had health data, PII data, whatever. So for the most part, the bulk of your data is business data that you can probably you probably best know how to handle. There are a few elements that create an outsized portion of your risk, both from a security breach perspective and also from a privacy regulation perspective. That's usually things like card numbers, because PCI industry doesn't care what information you store about me, as long as you make sure my card number and card holder data is secure. Health, there's different standards, different ways to address them. But if you were, for instance, to take the safe harbor approach of HIPAA, there's like 18 or 19 identified element types. Right. I could go on, but essentially the point is that there is a certain type of data on which, once you basically limit the type of data, it's names, it's date of birth, it's social security numbers, it's card numbers, the operations that are performed on this are very well understood. So what the data privacy vault is two parts. The data vault, basically, the vault holds your data. The vault lets you access the data appropriately, and the vault will basically give you the right governance tools, etc. Vault, of course, secures the data for you, so you don't have to. But more importantly, the vault helps you govern the data, so you can convert your requirements into access control policies very easily. Now that's great. It's a good data vault. What makes it a privacy data vault is that we understand privacy-related types, like the examples I was giving, name, date of birth, email addresses, and we allow easy operations across them. I want to send an email to user number 35. Let's build an email integration. I want to charge the user 35's card. Let's give you an integration for doing precisely that. I want to perform a certain computation on social security numbers, extract the last four, so my customer service portal can pop that up to the customer service agent so they can verify the customer. Don't reveal the full social security number, just the last part of it. So these kind of operations, once you understand the operations, once you understand what needs to be done with them, you can give the right tools, then the right language, the right governance framework for developers to build their system so they get minimal exposure to the sensitive information. We build all of that along with all the security controls that you would have to handle if you were touching all of the data to remain in compliance.
Yeah, so it sounds like basically the key here is that where the Skyflow Data Privacy Vault is providing secure storage as well as governance, so you can control essentially like who, what, and where that data is actually used and seen. But additionally, what makes it essentially a privacy data vault is that the vault actually understands the types of operations that you're going to perform essentially with this type of data. As you mentioned, it's a finite number of things that you're going to do. For example, with a credit card number, you might need the last 4 digits of a credit card number, or maybe you need the first 6 digits for the BIN number. But everything else other than performing a transaction against a credit card through a card network, most people or most operations don't need the full credit card number.
Yeah, that's a good summary. And we should have had you answer the questions.
So I guess what makes Skyflow unique versus like traditional approaches to data security and privacy that we kind of touched on earlier?
So the traditional approaches would mostly kind of be along the lines of here's how you go secure system X that accesses the data or system Y that stores the data. Put them together. Here's how you make sure that well, if you're caching it as well, then you need to make sure you also go into the caching system and make sure you got some. So the traditional approach, basically, it's kind of almost like you're trying to solve the problem at an infrastructure level when the problem is really not your infrastructure. As I said, please don't read it as Skyflow saying don't secure your infrastructure. You should definitely do that. But even after you've secured your infrastructure, you still have a problem of securing the data itself. And you can keep adding layers, or you can make sure that the solution itself is moved to a different place, and you just have to govern that with the right policies and rules.
Mm-hmm. Okay. And then given that Skyflow is essentially bringing something new to market in the form of this data privacy vault available as a service, what are some of the engineering challenges that Skyflow has had to solve or overcome to bring something like this platform to market?
Right. So that's essentially why we exist as a service. And the most important thing out here is it's not that Skyflow invents a new type of encryption algorithm, etc. You should never trust anybody who says like we've got our own proprietary encryption algorithm, things like that, right? But what Skyflow brings to the table is an approach that really prioritizes all the things that you would have to do to kind of do it all on your own. So you got to believe everybody not to have encryption at rest all the time. You got to have encryption in transit all the time. It really slows down your operations. If every single time you got service A that needs to talk to service B needs to have encrypted communication and TLS set up for internal communication and things like that, many services you could reasonably argue don't need it. And when you are hiring your infrastructure engineers, if you're not Skyflow, that is, if you're hiring your infrastructure engineers, your developers, they probably want the agility of being able to develop systems that don't have a very very high security privacy posture to be able to do what they need to do. And then we'll go figure out what additional controls to layer on top of that, right? Skyflow takes security, since we were built for this, we take security as part of our essential DNA. So even if it takes us 2x as long to do something, we basically make sure we do it the right way. We from day one, we look to solve problems that are very hard to solve after the fact. Key rotations, for instance. It's very easy to go encrypt stuff, and then you have to figure out okay, now we've got certain problems to take care of, like this key rotation business. We architect our systems knowing that we will handle key rotation. That's not an option for us. So a whole bunch of problems that you would, it's not that key rotation is technically a hard problem. We know exactly what one needs to do when you do key rotation. It becomes a very hard problem when you take a running, functioning, buzzing infrastructure and say go rotate key number 10 now. So it's the engineering aspects of this that make it hard. And if you are not in the business of security, that's kind of overhead for you. for us, it's not overhead. It's nothing really more than the grand old argument that goes back to Adam Smith about specialization.
Mm-hmm. Yeah, I mean, absolutely. It's like, do you want your essentially your precious engineering resources spending their time on something like key rotation, which may or may not be a core competency, versus building whatever services or features that actually serve your customers and actually generate revenue for your business. And the consequences of screwing up something like key rotation is pretty drastic. If you've ever been locked out of your house, imagine being locked out of all the data that you've ever collected about a particular customer or something like that. So we only have a few minutes left.
What are you asking your most important engineer to do?
Absolutely, yeah. So we only have a few minutes left, and I want to touch on something that's super hot right now, which is generative AI. There's, as well as there's also been a lot of focus on secure data management. So I kind of want to touch on these two worlds together. Do you think there's an opportunity for businesses to leverage AI to improve their data security and management practices? And also, what are the potential risks in relation to data privacy when it comes to this new explosion of generative AI?
Well, I guess we've probably reached the stage where anybody who says, well, AI will not do that, this kind of has some explaining to do. I mean, other than like maybe if you're in a creative field or something, but even that with generative AI, even that's kind of becoming an interesting discussion, right? So obviously, I think AI is going to impact the space. I think for the most part, most people will probably see an impact from AI, not directly, as in not that how they're writing how they're securing the systems changes directly in this, but probably more like they'll be using tools that use AI in ways that they probably weren't before. And frankly, AI has been there in the security space for quite a while. There's lots of like we were talking about like S3 buckets, going back to this one example we had, right? There's a whole bunch of AI related tools that'll do things like detection of information. That's been around for quite a while. If you've got an attack in progress, detecting, like looking at various signals to piece together the fact that there is an attack going on. AI has been playing an important role in that, and will continue to do, of course. Similarly, like I'm pretty sure that's going to get extended to like right use of the data in terms of a privacy perspective as well. So AI is here to stay, and AI will be making more of an appearance as time goes by. What was the second part? I forgot. You have two parts.
The second part is there potential risks to the explosion of AI from a data privacy and security perspective?
Yeah. So that also has a couple of interesting parts. So first, of course, is when people say like, what can we do with AI? They obviously need data. So that's the most relevant risk to us, in the sense that you want to be able to give your machine learning scientists, etc., the ability to go access the data they want to. That S3 bucket we've been talking about, that S3 bucket contains the card numbers, but it also contains a whole bunch of very valuable information. You want to unlock this bucket for them so they can kind of do their thing, and you want to make sure that you don't expose yourself and your ML algorithms to unnecessary risk, right? So that's the very basic stuff. But I mentioned that you're probably already using tools that use AI. So yeah, I think that's kind of the couple of things to watch out for.
Okay. Well, we are almost at time, so I want to start to wrap up here. Manish, thank you so much for joining me in this conversation. Enjoyed it a lot. And hopefully everybody that's listening in got some value out of it. And if you are, working in this space, you're an engineering leader in an organization, and you want anything that we, Manish said and touched on today regarding data privacy, data security, you want to contact him or anybody else at Skyflow, you can check us out at skyflow.com. And hopefully you learn a little bit of something that will make you eventually sleep easier at night when it comes to your data privacy and security challenges.
Awesome. Thanks, Sean, for a great conversation.